So now that we know what an inverse is and how to find the inverse, right? Now we're going to move on to how do we find the inverse of a function if we're just given the function. We know how to verify and all that, we just don't know how to find the inverse. Well, the first thing when we go to find the inverse we want to do is rewrite the equation and replace x with y and y with x, okay? So you're basically, switching the variables, and then from there, all you're gonna do is now solve for y, okay? Sounds complicated, but it's actually pretty easy. Now, the first example here, find the inverse of this function here. And then they want us to graph both. Let's go ahead and graph this though. If I remember, the y-intercept, right, of this is 0, 3, and my slope is 2. So if I go to 0, 3, now I'm going to go up 2 over 1, up 2 over 1. All right, and right then and there I can graph the line, okay? But now we're going to go and find the inverse of this function. So instead of writing it f of x equals 2x plus 3, we're going to say it's y equals 2x plus 3. But now I'm going to rewrite this as x equals 2y plus 3. So what I did is I took this x and made it a y. I took this y, made it x. Now I'm going to go ahead and solve for y here. So to solve for y, I feel it's easier to rewrite the problem. But if you don't have to, you don't have to. I'm going to subtract 3 from both sides. I'm going to get 2y is equal to x minus 3. And then y is equal to divide everything by 2. And I would get 1/2 x minus 3 over 2. Now, if I were to plot that, right, my y-intercept would be at 0, negative 3/2, which is negative 1.5, and my slope is 1/2. So 0, it's going to be negative 1.5, and from here I'm going to go up 1 over 2, up 1 over 2. And now, if I graph this line, it would look something like that. Well, if I were to graph the line y equals x, with these two lines, this is the line y equals x. This is your original function, f of x. This is your inverse function of f of x. Does it look like the reflection over the line y equals x? Yes. Therefore, we know we are correct. Okay? So, if I asked you to find the inverse of f of x, all right, where x is not equal to 1, this is a little more challenging. I'm going to start by saying this is y equals 2x plus 1 over x minus 1, and then we'll convert it back to f of inverse x. So now what I'm going to do is rewrite this by, I'm going to say 2y plus 1 over y minus 1 is equal to, then I'm going to change that y to x. Now when I go to solve this algebra can be tricky and they're not all this difficult. But I'm going to multiply first everything by y minus 1. Because what that will do is it'll get rid of the fraction. So I'll have 2y plus 1 equals xy, or x times y minus 1. Now from here, I'm actually going to go and distribute this x. So I get 2y plus 1 equals xy minus x. And I did that for one reason, because my next step is I'm going to bring the 1 over here, but then I'm going to bring the xy over here. And remember, all I'm using is inverse operations. Now, if I rewrite this, I'm going to rewrite this as 2y minus xy equals, those go bye-bye, those go bye-bye, and then I'm going to have this negative x minus 1 over here. Now, if you remember how to factor out that GCF, what I'm going to do is pull the y out. And when I divide both of these by y, what am I going to have left over? 2 minus x equals negative x minus 1. Now from there, I'm going to go ahead and divide by 2 minus x. And that would give me y is equal to negative x minus 1 over, I'm going to rewrite this as negative x plus 2. Now the one thing they don't like in math is when these leading coefficients are negative. So what I'm going to do is factor out a negative 1 here. And when I do that, and I divide both of these by negative 1, I get x plus 1 over here. When I factor out the negative 1, negative x divided by negative 1 is positive x. Then positive 2 divided by negative 1 is minus 2. Well, what happens to these negative 1s now? They cancel out, and I get y equals x plus 1 over x minus 2. So when we write our final answer, what we're going to do is come up here and say f inverse of x is equal to x plus 1 over x minus 2. I understand this algebra could be a little bit challenging, all right, but you should be able to kind of persevere through it, okay? The next example are you-try problems. What I want you to do is try these two problems and come back and check your answers. So the first example here, all right, what we're going to do is interchange the variables. So we're going to say y to the third plus 1 is equal to x. And now I'm going to solve for y. I'm going to subtract 1. Y to the third is equal to x minus 1. How do I get rid of the exponent 3? I take the cube root. And y is equal to the cube root of x minus 1. And the second example, I'm going to interchange the variables. I'm going to put a y in place of x, so it's going to be 4 over y plus 2 is equal to f of x, remember, is the same as y, right? So we're going to change that y to an x. And now to solve this one, the first thing I'm going to do is get rid of the fraction by multiplying by y plus 2. When I do that, these cancel and I'm left with 4 equals x times y plus 2. Now, this is not one where you want to distribute. What I would do is just divide both sides by x. I would get y plus 2 equals, because these cancel out, 4 over x. And now all I have to do is subtract that 2. So y is equal to 4 over x minus 2. And how do we write our final answer? F inverse of x is equal to 4 over x minus 2. Go ahead, try the homework, and if you have any questions, let me know.